happening. But today, today we talk about the two different types of probability we have here. We have what's called theoretical probability. I don't know if I spelled that right, but I shall check. Theoretical, yes. And the other type is experimental. Experimental probability. Which one sounds more exciting to you, Alexa Lutz?
That's a toughie.
Theoretical or experimental? Maybe we should define first. Okay. What is the difference between these two? Well, if somebody says, well, theoretically speaking, it should be whatever, or theoretically speaking, we should have made it to the moon or whatever. Theoretical would be theoretical, Christine?
What should happen?
Well, it's by, this one is by calculating. And like Christine said, what should happen according to your calculations. Okay. For example, the probability of flipping a head when you flip a coin should be what? You take a coin, it should be a fair coin, you should get a probability of flipping a head. How many choices do you have? 2 heads or tails, how many of them are heads? Peter? 1. So your theoretical, your probability is 1/2. That means half of the time you should get a head when you flip it. Okay? This is theoretical because this is what the numbers say. This is what should happen according to what you write down or what you calculate. Experimental probability, children, is what actually happens when you do it. Which would mean this. Let's say I flip a coin, and I flip a coin 10 times. Here's my 10 flips, and I get a head, a tail, a head, a head, a tail, a head, a head. How many is that? 1, 2, 3, 4, 5, 6, 7. A tail, and a head. Experimental probability is what actually happens when you actually physically do it. And in this case, what was my experimental probability of getting a head? Well, I did it 10 times. How many of those 10 were heads? 1, 2, 3, 4, 5, 6. My experimental probability was 3/5. Okay, this experimental probability is actually doing the experiment and getting your probability. This one is doing it mathematically. Okay, now let me tell you, in a case like this, the more you do the experiment, really what tends to happen is the more the experimental probability ends up getting to this one. Here, a case in point is this. If you only flipped a coin 3 times, so I got a board or something. You got one here? Just flip it on your desk. We're going to write it down 3 times. So we do this experiment. You get what? What is it? A head, a tail, tail. Okay. So we only did it 3 times. And my experimental probability said that my probability of getting a head is 1 out of 3. If you did it in percentages, that's 30. 1 out of 3 times. Okay, but, Jacob, here's my case in point. The more you do the experiment, the more usually this comes up to what it should be theoretically. So Jacob, flip it for me another. Let's do 10 times. Okay, by the way, let's just write this up. In percentages, this is 33 and a percent. 33 and a third percent. So Jacob does another one, he gets a head. See, right now, I match up because it is 1/2. Alright, Jacob does another one. head. Now my heads have overtaken the tails.
Head.
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 Another head. And head. So now, after he did it there, now my probability kind of shifted the other way. My probability, it looks like it is 8 out of 10 heads, which is 4/5 or 80% of the time. But, Jacob, let's do it one more time. Give me 10 more, as fast as you can get it here.
Head. Oh, and tails.
Tail,
Head.
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 I think he's looking at the phone. Tails.
Head.
You just going the flip-flop side of it?
Head. Tails. Head.
Tails. So now, out of 20 times, we had 8 out of 10 here, and then we got 9, 10, 11, 12, 13, 14. 14 out of 20 there, which is about a 70% time heads. Notice how it went to 30% heads, and then here we went to 80% heads. Now we're back down to 70% heads. And if Jacob did this a million times, I can almost guarantee you that it'd end up being very close to 1/2 by the time he was done with it. The more you do it, the more experiments you do, the closer experimental comes to a theoretical probability. And that's just kind of just there. Now, some things you can't have theoretical probability for. Some things you really have to do the experiment for to get it. And a case in point of that, it would be if Christian shot 30 free throws. Oh yeah, it's right. You know, it's right in that closet there. You'll see it's in a orange, black case kind of thing.
No, he made 13.
I think if Christian shot 30 free throws and he made 18 of them, I don't know if that's good or bad.
He made 13 for 13 yesterday.
Okay. We can come up with his experimental probability. The probability that he's going to make his next free throw, we just use the numbers from our experiment, is 18 out of 30, which would be, reduce it down, 9 over 15, 3, 5. You know, he has a 3/5 probability or 60% chance of making his next free throw. Okay? You can't really do theoretical probability on something that's based on somebody's skill. I mean, I can't calculate what, just without the experiment and seeing this, there's no way you could calculate something like that in probability. Now, I could do, the theoretical probability of picking a girl, just blindly picking a girl out of 7th grade would be what? How many girls are there? Out of a total 20. Okay, but if I had everybody kind of bunched around and just blindly pick somebody, I might pick 5 or 6 boys, or I might pick 5 or 6 girls before the boys, even though the probability says I'm going to pick boys probably more often than girls. Okay, this is theoretical, experimental is actually doing the thing there. Lutz!
It's all together, but you have to count the heads and the tails. How do you know which one to count?
I don't know what that means.
I don't either.
How do you know which one to count? We counted them all.
No, I don't know how to explain this. I don't know how to explain this.
Well, you think about it for a little while. Now, let me ask you a question here. Okay, let's say Jacob flips ahead, 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 ahead. He flips 9 heads in a row. And I asked you, what's the probability that he'll flip a tail on his next flip? What is the probability he'll flip a tail on his next flip? Peter? 1/2. It doesn't change. Just because he's flipped 9 of these in a row, it doesn't change. The chance of him flipping that next one is a 1/2 that he's going to get a head or a tail. No matter what you do before it, doesn't change that last thing. Now, if I asked you globally, what's the probability that he's going to flip, heads this many times in a row, then that's a different probability. But it's 1/2. Every one is 1/2. Okay. By the way, the probability of him flipping 3 heads in a row, does anybody know what that is? What are the chances that he would flip a head, and a head? This is, by the way, the theoretical probability. And it's pretty simple to figure out. You take what the probability of each one is and multiply it together. In other words, this. Probability of him flipping a head is 1/2 there. Probability of him flipping a head is 1/2 there. Probability of him flipping a head is 1/2 there. The probability of all 3 of them happen back to back to back is 1/2 times 1/2 times 1/2, which is 1/8. 1 out of 8 times, if you flip 3 times, you should get a head. Now, how do we know that's true? Because we can make a tree diagram. Okay, which means this. On his first flip, sorry, I'll write it right here. What are your probabilities on his first flip? Either he's going to get a head or a tail, right? On his second flip, again, after his head, he could get another head or a tail from there, or he could get a head and a tail from there. So if you flip a coin twice, here are all your combinations. You could get a head and a head and a tail and a head, and a tail and a tail. Those are your sample space, your whole combination. Probability for the third, if he flips 3 times, each one of these, you're going to branch off with a choice of getting a head or a tail on that one. Okay, and these are all of his combination choices. He could get all 3 heads back to back to back. He could get the 2 heads and then branch down here to the tail, so it'd be head, tail. He could get the first head, go to a tail, and then go to a head with that one. Head, tail, head. Or he could get head, tail, tail. Okay, those are the different combinations when he starts out with a head. Well, if he started out with a tail, he could get a tail, head, head. You could get a tail, head, tail. What just happened there? You see that thing go crazy? You could get a tail, tail, head. Sorry. Tail, tail, head. And you could get a tail, tail, tail. How many different combinations are there when you flip 3 times? 1, 2, 3, 4, 5, 6, 7, 8. How many of those combinations were a head, head, head? Just one of them. There, that proves that our 1/8 probability, which we said back here, half times half times half, gives you that sort of thing there. And you can kind of figure out your probability of winning the lottery. Maybe you should do it before you ever buy a lottery ticket, because I think if you figure it out, you'll never, ever, ever, ever. How would you figure out the lottery? Maybe I don't know anything about the lottery. Does anybody know how many numbers there are? You have to pick like 5 or 6, right? But how many, 1 through what? Is the 1 through 50, 1 through 60, 1 through 50? What is it? What numbers can you pick is what I'm asking.
I think so.
1 through 50? Okay, so if it was 1 through 50, the probability of you picking 1, 2, 3, 4, 5 different, not just 5 numbers, there's probably 6 or whatever. Well, probably you getting the first one right. How many choices do you have? 50. So you get a 1 in 50 chance of getting the first number right. Probability of getting the next one right? It's actually not 1 in 50 because, yeah, you took 1 away because you got the first one right. So now there's only 49 choices left. 1 in 49. Probability of getting a third one is 1 in 48, and then 1 in 47, and then 1 in 46. If you want to figure out your chance of winning the lottery, if there's only 5 numbers and they go up 1 through 50, you can just multiply 50 times 49 times 48 times 47 times 46. Well, if these were just tens, this would be 10, 100, 1,000, 10,000, 100,000. but they're actually 50, so multiply that by 25, 100, it's way, way, way in the millions. Your chances of winning the lottery are incredibly small. But yeah, we do it, all in the name of what? Sponsoring schools. Yeah, that's about the whole. Look at page 403 in your books, will you please? Let's make sure we kind of get the gist of this.